Hi, welcome to this video on sig figs. Yeah, let's get started. So previously you've learned about precision and accuracy. So sig figs are a measure of precision. So to start off, the precision of a measurement is shown by the number of digits in the number that you report. So if you measure something with a ruler like this, 1, 2, 3, 4, look, it's 5 things. Okay, let's say that's 5 inches, and it also has 1, 2, 3. It also has the split it into 10. So this is from 1.0 to 2.0. So you have a line like that, and you're like, okay, how long is this line? And so you know for sure that it's 1, and then point, let's see, goes to 1, 2, 3, 4. Okay. Yeah. 1, 2, 3, 4. 4. And then those are the digits that you know for sure. And then you're gonna estimate one more digit. So I'm gonna estimate that's a 0.03, let's say. So that's what you wanna do when you're taking a measurement, is you're gonna go one more decimal place than what you know for sure. So you have 2 for sure digits, 2 known digits, and then 1 estimated. So however many digits you know, just always remember 1 estimated digit afterwards. So another little reminder is that precision does not guarantee accuracy. So you could have a scale balance that goes, let's just say it has precision to this is the little thing that tells you how much it weighs. Let's say it has precision to 0.00001, but that doesn't mean that it's accurate, because it could be that, it isn't calibrated correctly. So that's just something to remember. Don't mix up precision and accuracy. This number may be precise, but it may not be accurate. So the next big thing with sig figs is you want to know how to recognize the number of sig figs in a number that you see. So all right, so let's just start with an example. So any non-zero number is always going to be a sig fig. So you're given a number like this. Nope. Okay, you're given an example like this. Okay, 3,245. Now, all of these are non-zero numbers. So this, we would say it has 4 sig figs, because 1, 2, 3, 4 numbers that are not 0. All right. The next rule you want to remember is that zeros that are in between non-zero numbers are always sig figs. So let's just write the similar number, but actually it has a 0 there. 4, 5. This still has 4 sig figs, because all of these are important digits, okay? It's in between, it matters. You wouldn't say that this has 3 sig figs, because that wouldn't make sense. The next rule to remember is that all final zeros to the right of the decimal place are significant. So if you write a number like 0. So this is the number that you measure, okay? Now, there's a non-zero, 2, 3, 4 non-zero numbers, so at least 4 sig figs, but then there's also this number over here. Now, why is it included? It must be included because it's significant. So, there's no other reason for it to be included. It's not a placeholder, since it's not a placeholder, and it's at the end of, to the right of the decimal, and it's at the end, it's significant. So that's 5 significant figures. Yeah. And then, so that's 3 rules so far. Our 4th rule is that placeholder zeros are not significant. So I mentioned placeholder zeros here. Now let me show you what that would look like. That would be like 1, 4, 0. So you go 1,400. This has 2 sig figs because it's a non-zero and a non-zero. But other than that, these are just holding the places to tell you that this is in the thousands and this is in the thousand place and this is in the hundreds place. So 2 sig figs. All right. Something else is sometimes you get a number like this, but it does have 4 sig figs, and the way you would show that is by putting either a decimal point at the end that indicates that all of these numbers are significant. So that would be 4 sig figs, or that's pretty much the best way to do that. So if you see something that looks like that, that's what it is. It's indicating that those placeholder zeros are significant. And then our final rule is that counting numbers. Oh, actually, before I go on to the next rule, I want to go back to this rule about the number of sig figs when there are placeholder zeros. Another way that placeholder zeros could look is like this. So you have a 0.0038. Again, these two are just placeholders to show that the 3 and the 8 are in the thousandths and the 10,000ths place. So they're not significant. And so yeah, there's just 2 sig figs here. Those are placeholders. Now on to our final rule, which is that counting numbers and defined constants have an infinite number of sig figs. So what that means is when you're counting the number of something, so let's just say you have 5 cows. That's a cow. If you have 5 of them, you can't really have a partial cow. Actually, we only have 3 cows because 2 of them died. So there's 3 cows. Now, if you're using the number 3 cows in your calculations, it has an infinite number of sig figs. Now, this is only important because of what we're going to talk about next, which is adding and subtracting and multiplying and dividing when you do math with sig figs. So just know, if you're counting, it has an infinite number. In a chemistry sense, this would be used in something like counting the number of molecules. So if there's 6 molecules, you're not going to have 6.0 molecules. There's 6.5 molecules, you know? So infinite number of sig figs, but just write the number. Because it's not a measurement, it's a count. And then also a defined constant. So like this is usually like when you're using conversions of some kind. So you have 1 minute equals 60 seconds. Now this appears to have 1 sig fig, and this also appears to have 1 sig fig, but when you're converting between the two, they have an infinite number of sig figs, because let's say you have like 38.5 seconds and you want to convert it into minutes. If you were to say, now I have 38 seconds, 60 seconds, 1 minute, cross out seconds, this divided by 60, is a number that I don't know, but it's 0.642. So the reason I wrote 3 sig figs here instead of just 1 is that this would have an infinite number of sig figs because it's a constant. It's a defined constant. So you go with this number of sig figs, which is going to match your answer. Alright, so having explained those rules, some of them would make more sense if I also explained what to do when you're adding and subtracting numbers in relation to sig figs. So adding and subtracting have the same rules, and multiplying and dividing have the same rules as each other. So when you're adding and subtracting, what you want to do is find the number of sig figs, line up the okay. Yay, that's a decimal point. You're adding, and you want to add you want to use the number that has the smallest amount of sig figs. So this has 3 sig figs, that has 6. When you get your answer should have the same number of decimal places as the smallest number of decimal places for this. Okay, so you see, I had this. We only want 2 decimal places because this says 2 decimal places, and that's the smallest number of decimal places. Same thing with subtracting. For multiplying and dividing, you're actually just going to use sig figs, normal, not weird decimal place. So 13 times 5.83. Now 13 has 2 sig figs, 5.83 has 3 sig figs. You're going to use the smallest number of sig figs, and that means that your answer will have 2 sig figs. So those are the basic rules of significant figures, and I hope this helps.